3 years after Balmer proposed his empirical formula for the hydrogen atomic absorption spectra, Ryderberg modified his formula in order to find a more general formula to explain other absorbed hydrogen absorptions. Because after, apart from Balmer's formula, which can only describe one of the series in the hydrogen absorption, namely the Balmer series. Apart from Balmer series, there are others such as Lehman and Pathon. And so we can understand, it is understandable that why Ryderberg want to modify Balmer's original formula. Here is a brief description of what Ryderberg had done, together with some remarks from the new perspective. We know that the Balmer's formula can be written as lambda equal to, now I use a constant, B multiply m squared divided by m squared minus n squared. So this is a Balmer's formula. And where n equal to 2, m are the integers from 3, 4, 5, and so on. So what Ryderberg did first is to rewrite his formula as its reciprocal form. So he write 1 over lambda. Then we got this side will be 1 over b, and m squared minus n squared divided by m squared. Okay, so this can be simply rewritten as 1 over b, 1 minus n squared divided by m squared. Furthermore, we can rewrite this, we can factorize n squared, we can factorize n squared, so that we got the two similar terms, the difference of two similar terms. One is 1 over n squared, another is 1 over m squared. Okay, so in this way, Ryderberg obtained his new formula. R is Ryderberg constant. That is 1 over n squared and 1 over m squared. Obviously, the Ryderberg constant is equal to n squared over b, or 4 over b, because n is constant, 2. This is Ryderberg's work in 1888, okay? And 10 years later, electron was discovered by J.J. Thomson. And by 1900, the quantum idea was proposed first by Max Planck. So this is Planck's work. That the energy of photon can be written as h multiply the frequency, or in terms of wavelength, which would be h multiply speed of light and divided by wavelength. Actually, Einstein used this formula to explain the photon electrical effect in 1905. I'm sure that Ryderberg must have known this new development in the quantum mechanics. If he could follow this trend by rewrite his formula into this form, say, if we multiply hc divided by lambda, and then he can easily obtain a new formula, which is 1 over n squared minus 1 over m squared. Both n and m are integers. because in this equation, on the left-hand side, it represents the energy of photon, okay? So the right-hand side must be also represent the difference of certain type of energy. In this case, there's no other choice but the total energy of hydrogen atom. Okay, and in addition, it must be negative because that energy is a potential energy, is not a kinetic energy, presumably. So therefore, we have to, oh, of course, not necessary, because they just pay his original equation. This equation can be further rewritten as R. Can we just put this, rearrange this formula as RHC divided by m squared, negative, you see, put a negative here. Take away of the negative RHC n squared. Okay. Now, in this case, because as we argued that because the left-hand side is energy, photon energy, so the left-hand side must be the difference of two energy, okay, of this energy. So therefore, it is very, it's very easy, right, to work out that this term might represent some type of energy, a discrete energy. So that is RHC divided by n squared. Okay. So if you could have recognized these important terms, then he may have improved or rewrite to modify his formula by incorporate the quantum idea. So his formula can be simply written as the photon energy, H frequency, equal to the change of the hydrogen atomic energy, delta E sub n. So of course, this equation eventually explained by Niels Bohr in 1913, after the discovery of the nuclear model for atom by Rutherford. So, but this formula could have been derived by Ryderberg himself, if he could, follow up the new development in quantum mechanics. Also, it's very important to notice that if this formula also shows that it is more important to find the formula of the total energy of hydrogen atom than to work out its orbit or in terms of the Niels Bohr's atomic models. Actually, in my opinion, this would be a perfect shortcut to derive the exact expression, mathematical formula for energy. Although as in this formula that we still have used some empirical constant, but this formula is so important, okay? And it could have been discovered by Ryderberg. That's my comment. To summarize briefly, so this is a formula derived by Balmer in 1885, and this is the formula derived by Ryderberg in 1888. And this could be, before we go further, so this is Balmer's. 1885. And this could be Ryderberg's formula around 1905, I hope, I wish, but it didn't happen. Okay. It could be a formula, named after Ryderberg in the history of atomic physics. I hope this introduction will give you some, details and also some of dramas in the history of development of quantum mechanics. Goodbye.